Good morning, guys. Welcome to day 18. We're going to be looking at how to divide rational expressions today. Should be a pretty short lesson. There's not a whole lot of new material, just a trick to understanding how to do the material better when you're doing division problems. That being said, I will go through a couple of the problems from last time, because I assigned a very long homework assignment last time, more than normal, and so that seemed a little unfair. I will do a couple of those problems with you guys, so you can kind of see some review of last time's material at the same time. I apologize if I sneezed today during the recording. I don't want to, I promise. Let's go ahead and get started. I'm going to start by doing number 20 and number 22 from the homework assignment. This is because each of these involves the AC method and they take a little bit longer than normal. And then afterwards we'll showcase kind of the simplistic way we do division of these same problems and do a couple practice problems and finish out. So here we go. So let's look at number 20 and number 22. Number 20 states, we have the following problem. 6x squared minus 5x minus 50 divided by 15x squared minus 44x minus 20 times, 20x squared minus 7x minus 6 over 2x squared plus 9x plus 10. Alright, for this problem, because of how it's situated, I have to, step 1, factor the tops and bottoms, the numerators and denominators of each of these fractions. So, I need to factor the top piece and the bottom piece of the first, then multiply it to the factored version of the top and bottom of the second piece. So, let's go through it one piece at a time. 6x squared minus 5x minus 50 is the first one I'm going to do. I'm going to use the AC method. 6 times negative 50 would be negative 300. The two numbers I multiplied were 6 and negative 50. I want them to add together to be negative 5. In this case, those numbers would be negative 300. This would be negative 20 and positive 15. So remember, I want two numbers that are going to multiply to my top number and add to my bottom number. Negative 20 plus 15 would be negative 5. So I do factor by grouping. 6x squared minus 20x plus 15x minus 50. I then group them together and get the following. I can factor a 2 and an x out, so 2x times 3x minus 10. Over here I can factor a 5 out. Yes. Let's take a 5 out. Gives me 3x minus 10. These two match, so I know I've done it right. This would become 3x minus 10 times 2x plus 5, and that makes my first factor. 3x minus 10, 2x plus 5. And again, I can verify that's right by simply doing FOIL again. Okay, next one. The bottom, so that would be 15x squared minus 44x minus 20. In this case, my numbers are 15 and negative 20. If I multiply those together, I get negative 300. I know that because I just did it. And I want them to add together to negative 44. I think it's negative 50 and 6. Negative 50 times 6 would be negative 300, but when I add those together, I get negative 44. That looks pretty good. Okay, just like before. 15x squared minus 30x plus 6x minus 20. And then I group them together. This first one, I can take a 5x out. I can take a 15x out. Oh my gosh. 15x out. And then what's left behind would... Wait a minute. That's a 50. I wrote 30. Always double check this stuff, because there's where you're most likely to have your most problems. Okay, so it should have been a 5x. So I take 5x out. What's left behind is 3x minus 10. I take a 2 out, leaving behind a 3x minus 10. That's good, because they should match, which gives me 3x minus 10 times 5x plus 2. So I come over here, 3x minus 10 times 5x plus 2. Now this is good, because I can already see that these two are going to end up canceling here in a little bit, which is great. But I got to keep going. I got 2 more I need to check. Let's see, my next one was 20x squared minus 7x minus 6. Okay, if I do that, I'd end up with 20 and negative 6. It gives me negative 120. Now, numbers that multiply to negative 120 but add to negative 7. 12 and 10 wouldn't work. Negative 15 and positive 8. Negative 15 times 8 should be 120. Negative 15 plus 8 should be negative 7. That looks good. So I get 20x squared minus 15x plus 8x minus 6. I group. This would give me factor of 5x out. So give me 4x minus 3. Factor a 2 out. This would give me 4x minus 3. They match. It's a good sign. So I end up with 5x plus 2 times 4x minus 3. So 5x plus 2 times 4x minus 3. So as you can see on some of these problems, the actual mathematics, the actual multiplication is going to be the easy part. It's this part that's going to be the pain. It's going to be finding all of these different factors. Because the only way I can simplify is if I can cancel them, and the only way I can cancel them is if they're in factored form. So I have to take time to do these steps. Continuing. My last one is 2x squared plus 9x plus 10, which means I want 2 and 10, which would multiply to 20. I want them to add to 9. That's 4 and 5. So in that case, I'll do my work over here. If I multiply these out, you'd get 2x squared plus 4x plus 5x plus 10. From here, we group together, giving us 2x times x plus 2, and then plus 5 times x plus 2, giving me a total of x plus 2 times 2x plus 5. So we get x plus 2 times 2x plus 5. Alright, this is looking good. Once again, I look over here. I don't see anything that cancels directly, but maybe we'll get lucky in a second. Now, the cool thing is you can shortcut this a little bit because you know you're going to multiply tops and bottoms, so basically these two just become one big fraction with the tops and bottoms being multiplied. So I can actually cancel from here. I can cancel this with this. I can cancel this with this. And I cancel those first ones, which means that the only ones that are left on top are 4x minus 3. The only ones left on bottom are x plus 2, which means my solution is, well, of course, 4x minus 3 over x plus 2. That is so much simpler than what I started with. Like, that's almost frustratingly simpler. Because, you know, look at how complicated and nasty this thing is, and look how nice the end result is. Like, I almost hate it. And if you're like me, you might hate it too. Just because in these kinds of problems, it can be tedious to work through and find these factors to just get such a nice answer. But that's how it works. Let's look at 22. Same way. 22, we have 2n squared minus n minus 15 over 6n squared plus 13n minus 5 times 12n squared minus 13n plus 3. divided by 4n squared minus 15n plus 9. Alright, just like before. Now if you're good at finding these factors, you can do it quite a bit faster than how I'm doing it. But I'm showcasing all of my steps just to make sure I get it right. So up here, I'm going to go ahead and do 2n squared minus n minus 15. My numbers in this case would be 2 and negative 15. Those multiply to negative 30, but add to negative 1. That would be my numbers in this case are negative 6 and positive 5. So we end up with 2n squared minus 6n plus 5n minus 15. We group. Take a 2n out, so 2n times n minus 3. Take a 5 out, resulting in n minus 3. So we get n minus 3 times 2n plus 5. So our first parentheses, n minus 3, 2n plus 5. Alright, next one. We have 6n squared plus 13n minus 5. My numbers in this case are 6 and negative 5. Those will multiply to negative 30. I need them to add to 13. This would be positive 15 and negative 2. So we have 6n squared plus 15n minus 2n minus 5. Okay, over here I can take a 3n out when I group them together, resulting in 2n plus 5. Here the first one is negative, so I should take a negative 1 out, but there's no other number or variables to come out, leaving me a 2n plus 5. Remember, when I factor out that negative, it comes from both of them, so the negative 2n becomes positive 2n, the negative 5 becomes positive 5. This ends up being 2n plus 5 and 3n minus 1. Go over here, 2n plus 5. Oh, isn't that nice? Those two are going to cancel. And 3n minus 1. So, one part done. Okay, next one. I have 12n squared minus 13n plus 3. My numbers in this case are 12 and 3. I multiply those, I get 36. I want to add to negative 13. That would be negative 9 and negative 4. Negative 9 times negative 4 is positive 36, but when I add those together, I do get negative 13, so that's good. Next, I split them up. 12n squared minus 9n minus 4n plus 3. Group them. I can take a 3n out, giving me 4n minus 3. I can take a negative 1 out, because again it's negative 4n, so I should take a negative out, give me 4n minus 3. Remember, if I take the negative out, I've got to take it from both of them, so negative 4n becomes positive 4n, positive 3 becomes negative 3, which is good because these need to match for this to work. This becomes 4n minus 3 times 3n minus 1. So 4n minus 3 times 3n minus 1. Now I do the last one, which is 4n squared plus, no, it's a minus sign, minus 15n plus 9. Okay, I multiply these together. 4 and 9 become positive 36 again. I want it to be a negative 15 this time. To make it a negative 15, I would use negative 12 and negative 3. Those multiply to positive 36, but add to negative 15. This becomes 4n squared minus 12n minus 3n plus 9. A group. I can take a 4n out, leaving behind n minus 3. I can take a negative 3 out, leaving behind n minus 3 again. Taking a negative makes that become positive, which makes this become 4n minus 3 times n minus 3. So we have 4n minus 3 times n minus 3. This one has this cool little thing that happens, okay? So the n minus 3 is going to cancel with the n minus 3. 3n minus 1 is going to cancel with the 3n minus 1. The 4n minus 3 is going to cancel with the 4n minus 3. So all of these have canceled. But remember, on top, there's always a 1. And on bottom, there's always a 1. So when this simplifies, everything cancels except the 1 on top and the 1 on bottom. And 1 divided by 1 is, of course, 1. Which makes this even worse than the previous one, because when you multiply these two, they end up becoming just 1. Like, I hate you a little bit. How dare you? Frowny face. Okay? But that's how the math works. And in fact, if you were to take this function and actually multiply these two things, your result would always be 1. Because that's how they simplify. It should be 1. This was last time's review. Today's material is not much different. In fact, it involves very much the same steps. And so that's why I decided to put these two together. This involves dividing rational expressions. So once again, this has got a process to it. Step 1. You need to rewrite the second rational expression as a multiplied reciprocal. If you don't remember your terminology, reciprocal just means the flipped version of a number. So like if I have a divided by b, then the reciprocal is b divided by a. So what it means is you're going to take your second fraction and flip it over and change it to multiplication. That's the big detail. Now, after that, just multiply. Like before. And so really, division just adds one extra step. It's just the step is really important. I'm going to do 2 examples for sure, and if I have time, I'll do a third. Let's take a look. So I have 2x squared plus x minus 6 divided by x squared minus 1. Division symbol. Now I have x squared minus 4 over x squared plus 2x plus 1. Okay, so step 1 says we're going to rewrite this. Specifically, we're going to rewrite the second rational expression, so the first is not going to change. So the first stays 2x squared plus x minus 6 over x squared minus 1, so that stays the same. We're going to change it to being multiplied, but now instead of using this fraction, we're going to use its reciprocal. So instead of x squared minus 4 being on top, it's going to be x squared minus 4 on bottom. Instead of x squared plus 2x plus 1 on top, we're going to have x squared plus 2x plus 1 on top. So this is the first major step. You have to rewrite only the second one. From here, everything is the same as before, where we're going to use the reciprocal now as a multiplication problem, and so our goal becomes to factor each of these. Now, I know how to factor these mentally for each one of these. You can check my work if you wish. I strongly recommend it. There's always a chance I make mistakes. Let's start with the bottom ones because it's the easy ones. X squared minus 1 is difference of squares. That becomes x plus 1, x minus 1. X squared minus 4 is also difference of squares. It becomes x plus 2, x minus 2. Remember, because you take the square root to put it in. So square root of 1 is 1. That's why these are both 1s. Square root of 4 is 2. That's why these are both 2s. Over here, this one is actually just, this is the perfect square formula. It's actually x plus 1 times x plus 1. The only tricky one is actually this one over here. which I could use any technique I wanted to solve. I can use the AC method, which I'll do over here. I got 2, -6. 2 -6 is -12. And they should add together to +1. That'd be +4 and -3. So we end up with 2x squared plus 4x minus 3x minus 6, a group. This becomes 2x times x plus 2. Let's take out the -3. This becomes x plus 2. And so you can see, like I said before, knowing these pieces is not required, but it makes you faster. Like, I would have had to do, just like on the previous ones, all those other same steps for these three if I didn't know my shortcuts. But because I know my shortcuts, I only need to do it once, which made me a lot faster. Now, just like before, I'm going to cancel out what's in common. X plus 2, x plus 2. X plus 1, x plus 1. X minus 1 has no match. X minus 2 has no match, so that must be it. Meaning that the solution for this problem is 2x minus 3 on top, and an x plus 1 on top, all over x minus 1 on top, and x minus 2, on bottom. This is one acceptable solution. If you wish, you may go ahead and distribute, but that is entirely up to you. I do not require it. It's just for extra practice. So on the bottom, we get x squared minus 3x plus 2. On top, we would get 2x squared minus x minus 3. And so this is also an acceptable solution. So again, notice that the big difference is there's a first step. We have to use the reciprocal property to rewrite the division into multiplication, and then the rest is basically the same. So if you didn't feel like there was enough practice last time, there's more. Okay, second example, just to verify that concept one more time. In this case, I'm going to use x squared plus 11x plus 30. Nope, I'm looking at the wrong example. This is from a different section. Okay, 9x squared minus 16 over 3x squared plus 17x minus 28 divided by 3x squared minus 2x minus 8 over x squared plus 5x minus 14. Okay, just like before. Step 1, we're going to rewrite this. The first one stays the same. 9x squared minus 16 over 3x squared plus 17x minus 28 times. Now we flip because it's reciprocal. So we'd have x squared plus 5x minus 14 on top. On bottom we have 3x squared minus 2x minus 8 on bottom. Okay, just like before, we're going to take our steps, and now we're going to write the factored forms of these. Now again, some of these I already know. I'm going to go ahead and merge them together in one step because, you know, it's the same. I don't need to write two steps for that. This first one is the difference of squares again. So this was, the square in this case would be 3x and 4, so 3x plus 4 and 3x minus 4. On bottom, I'd have to use the AC method. I'll get to that in a second. The top one up here, I can do that as a shortcut. X plus 7 times x minus 2. So it looks like I'm going to need two AC methods to make this work, so I'm going to do that over in this corner. So the first one is 3 and negative 28. If I multiply those together, I would end up with negative 84? Seems right. I want them to add to 17. Let's see. This would be positive 21 and negative 4. Oh, that's nice. Okay, so I would do my pieces. That would turn this into 3x squared plus 21x minus 4x minus 28. And then group them together. Take a 3x out, leave behind x plus 7. Take a negative 4 out, getting an x plus 7. I end up with 3x minus 4 times x plus 7. So I have over here 3x minus 4 times x plus 7. That's looking good, because actually both these will end up canceling. Okay, my second component, which was the 3x squared minus 2x minus 8, my pieces in this one would be 3 and negative 8. Those multiply to negative 24. I want them to add to negative 2, which makes my pieces negative 6 and positive 4. So I get 3x squared minus 6x plus 4x minus 8. I then can factor from the first two a 3x out, giving me x minus 2, and a positive 4 out, leaving me x minus 2, giving me x minus 2 times 3x plus 4. So I would have x minus 2 times 3x plus 4. Well, that's looking real nice. Let's see what happens. So 3x plus 4 and 3x plus 4. 3x minus 4 and 3x minus 4. X plus 7, x plus 7, x minus 2, x minus 2. Look at that. We end up with a 1 on top and a 1 on bottom, which means the answer is 1. So, as you can see on these kinds of problems, the biggest trick is going to be, can you factor these quickly and effectively? If you can't, you can spend an hour on this assignment tonight, same as you could have on the assignment last night. And to me, I don't view that as my problem. I'm not going to lie to you. I'm an evil man. When I look at this, I sit there and say, I think you should be better at factoring. Either get better at factoring or accept the fact that you will take more time, and that is you that needs to understand that. I'm sorry, that's the way it is. I wish it was different. But you can't get around the fact that if you can't do these problems quickly, then you're going to need more time. Now, that's why the test will be, given plenty of time, or at least your quiz will. Same with your test. Like, you'll have the time you need, so please use it. But know that you will be faster if you do it this way. That's it for today. No other new materials. That took plenty of time by itself, and the homework is already busy enough. So that'll be it. I'll be signing off today. Have a good rest of Wednesday, and I will see you guys for our final assignment of the week tomorrow.